This is the first time I've done one of these sorts of talks online. I want to first start by just sharing with you the type of research that I do, because it's a little bit different than a lot of people at the Marine Institute. I have a couple of videos here. This video here is actually Kasparov, a famous chess grandmaster, and it shows him getting beaten by Deep Blue, the IBM computer. So here he walks off exasperated. A computer has finally beaten this brilliant man. But if you notice, there's this little guy back here in the background, and he works for IBM. It was his job to move the chess pieces around the chessboard. And that's because we don't have robots that can do that very easily. Now, I want you now to look at this video here. This video is professional soccer players, and I just want you to appreciate the elegance of the coordination of the hand, the eye, the head, the anticipation. It truly is like a poetry in motion. Now, I want you to compare that to this. This is the Robot World Championships for soccer. They hold them every year. And this is state-of-the-art in robotics for soccer playing. So you can see we're not able to program robots to move with the elegance or coordination of a small child, really. And that just highlights the complexity of motor control. And that's what my research is about. I study how we become expert at skills and how we can even develop just basic competencies at skills. I've been doing that work from the Ocean Safety Research Lab. You've probably seen this glass door on the main hallway. We have a group of postdocs, graduate students, and researchers all looking at various aspects of ocean safety research. My research is focused primarily on simulation and how we use simulation to learn all things marine. So how to use simulation to learn safety and survival skills, marine navigation, search and rescue skills, helicopter hoisting for SAR. All of these skills can be learned and are learned in simulated settings. And another exciting thing is we have new graduate programs that just started up. So we have master's and doctoral programs in ocean safety, and they just started in September, and we have an intake of 5 students, and we're looking forward to to growing the program in future years. So today, specifically, what I want to talk about is working in the cold, working with cold and wet hands. There's lots of examples you could think of in, in the marine world where you're going to be working in these types of environments. A deckhand, on a ship, workers in the oil and gas industry, passengers in helicopters. The photo at the bottom is from a Coast Guard helicopter that went down, I think 2013. And what you see in these helicopters is when they crash, they turn upside down, like the position of this helicopter, and people have to egress. And they will egress these helicopters into very cold waters, and they'll be doing it with bare hands. And that is certainly an issue, because if the hands are cold and then they get essentially numb, and you can't perform the skills that you need to survive. So, for example, pulling something over your I can't think of the name. So I'll just move on here. So here's an example of someone who is training at a simulation center like the OSSC, the Offshore Safety and Survival Center. And you'll notice that this person who's training has bare hands. And the reason the hands are bare during training, one is so that it's for safety, so that the trainee has enough dexterity to perform the skills that they need to perform, and they can do it safely, but the water's warm. Now here, this is also a training session that would be done obviously in the real water. And I mean, clearly the people here are going to have their hands covered. This is a photo of a number of fish harvesters that were caught in the ice. So it's an example of where people, obviously in the fishing industry, are exposed to very cold temperatures. And here's a scenario where a number of fish harvesters have to abandon ship, and search and rescue crews are on their way to rescue these harvesters. And all of these individuals, the search and rescue crews as well as the harvesters, are going to have to deal with cold hands to perform the skills required to survive. Here's some other examples in aquaculture, food processing. And you'll note that the gloves that the food processors are wearing there's no thermal protection there at all. So these people on a daily basis are exposed to cold temperatures that could eventually damage their some of the nerves in the hands. And I also want to mention what goes on in the labs as well. We've been talking a lot in our lab about lab safety. And many of you scientists that work in fisheries, you may be exposing yourselves to cold water on a regular basis. This study here was a review of lab safety published in Nature Chemistry. And the first question they asked scientists was whether or not they felt their lab was a safe place to work. And most people, represented by sort of the red bars, agreed that their labs were safe places to work. And then another question below that they were asked is, have you ever sustained an injury while working in the lab? And over almost half of the respondents said yes, they have had an injury at least one or more times. So that would be really unacceptable in most workplaces to be exposed to injury, that frequently. And it's just something that I thought I would highlight, that as individuals working in fisheries and potentially exposing your hands to cold water on a regular basis to do the research that you do, you are actually exposing yourself to potential cold water injuries. So I just want to talk a little bit about the research that describes how the cold affects human performance. Generally, between 20 and 30 degrees, if the hand is in water is 20 to 30 degrees, dexterity is not really affected. But after 20 degrees, there is a rapid drop-off to 8 degrees. Now, this particular review only goes to 8 degrees because most research that looks at how exposure to cold affects dexterity never has gone colder than 8 degrees. However, we know that the oceans around Newfoundland and Labrador are certainly colder than 8 degrees in the wintertime. They can be as cold as -2 degrees. And that's the type of exposure that people are getting who work in the waters. So one of the one of the projects that we did in our lab was to examine what happens when we expose the hands to 2-degree water, and that's as cold as we could technically get our water. We measured a number of things. We exposed people to 2-degree water for about 2 minutes, and it was a very unpleasant thing to do. It was quite uncomfortable. We measured the touch sensation. The first circle up here shows something called the voluntary hair test, and it's a hair filament that you'd press in the finger, and it would bend, and then you would report whether or not you could feel it. And these hairs are calibrated such that from the thinnest hair to the heaviest hair, there's various levels of sensation that you could perceive. And then there was the middle 2 circles represent various pegboard tests. One is the Purdue pegboard test, and the other is the Groove pegboard test. These are clinical tests that have established norms for performance that we use to measure motor performance. And in the bottom circle, that represents a task of untying knots. And we were trying to think of a task that had some practical relevance. So if you were in a lifeboat or a life raft in an emergency situation, you would have to untie sort of the emergency survival kit that would be strapped into the inside of the raft. So we had people dipping their hands, holding their hands into a tub of cold water. They would pull their hand out, and then they'd experience these various tests that I described. So what we found was that for the not untying times and Purdue pegboard scores, that if you're exposed to cold, you did worse. And if it was cold and wet, you did worse yet. So the Purdue pegboard scores, higher is better. That means you've gotten more pegs in within a 30-second period. So the lower scores of the cold and wet. Now on the right-hand panel, the not untying times, if the times are higher, then it took you longer, your performance is worse. So what we see here is that exposure to cold and wet is even worse, is the worst performance. So how quickly do you become impaired when you're exposed to cold? So we had people put their hands in the tank for 30 seconds, and then we tested them 60 seconds, 90 seconds, and 120 seconds. There was a linear relationship where the longer the hand was exposed to the cold, performance deteriorated, and at 90 seconds, we actually saw a statistically significant difference. But there's a clear trend. So even within 30 seconds of exposure, your pegboard scores are going to be worse, and your tactile sensation is going to be worse. So it happens very quickly. So we've established, and it's well established in the literature, we've established and reiterated at the 2-degree temperatures that performance is impaired. So now we're asking, what can we do is there anything we can do to fix this? So what we did is we trained people. We thought if you had experience in the cold or training in the cold. So we had a group of people that were trained in the cold and a group that were trained on the same skill, but in a thermoneutral or a warm temperature. And then we tested them in the cold. And there was really not a large difference. So there was a small advantage where the cold trained group performed fewer errors than the thermoneutral trained group. So it appears there was a small effect of training, but it wasn't really significant. And this brings us to Wim Hof. because Wim Hof is a very famous character. You may have heard of him. And he says that, cold exposure you can train yourself through cold exposure. And so he has a program. He's a fellow who's born in the Netherlands, and he's known for his ability to withstand freezing temperatures. So he has set Guinness World Records for swimming under ice. He goes 57, he can go 57 meters under the ice. And in fact, they had to stop one of his training exercises because his corneas froze and he couldn't see. He has a world record for prolonged full body contact with ice. That's 1 hour and 53 minutes. So that he just goes sort of naked into a bucket of ice. And he holds the record for barefoot half marathon on ice and snow at 2 hours and 16 minutes. So and these are just some of the sort of the feats that he's performed. And he attributes these feats to the Wim Hof method, which is a combination of frequent cold exposure, breathing techniques, and meditation. And remarkably, he has a twin brother, which is really interesting. And so some scientists put both Wim Hof and his twin brother into a cold chamber, and neither of them started shivering. And they showed the same similar sort of biological responses in terms of blood chemistry. They did a number of physiological tests. So physiologically, him and his brother seem to have a ability to tolerate the cold. However, when asked about their comfort levels, now Wim Hof reported that he, in spite of being in this cold chamber, he was quite comfortable, and his brother said that he was cold and uncomfortable. So that was the only difference about them. It was the way they perceived the cold. So, maybe Wim Hof's training is just about cold perception. So what we wanted to do is to see if we could replicate in the laboratory some of Wim Hof's techniques. So we had groups of people. One group was exposed to cold, and this is just the hand in a bucket of cold. Another group did the same thing, but while they had the hand in the bucket of cold water, they were doing mindfulness training. So they were like kind of repeating. They had a mindfulness script that was read to them, and they did sort of deep breathing techniques. And what we found was that the group that had mindfulness training did not perform any better than the group that did not have, just had the cold exposure. So it didn't affect performance. But what it did affect was the duration of time I guess a small difference, but it was a significant difference. The amount of time that the mindfulness group could hold their hand in a bucket of cold water. So we had them say, okay, put your hand in the water as long as you can. And if you've ever done this, when the water's like 2 degrees, it's painful. In fact, researchers who study pain use cold water exposure as their way of inducing pain, because it's a relatively safe way to induce pain. So anyways, this mindfulness training did is it allowed people to submerge their hand for a longer period of time. But that was just sort of an acute training and acute exposure. We wanted to look at what happens with chronic exposure, because we thought that maybe if we look at people who have chronic exposure to cold water, we would guess that they would be more tolerant to that cold. So what we did is we tested a group of fish harvesters who had 25 years experience fishing. They fish 6 months a year. And we had them do a number of tests, and we compared them to a group of just age-matched control. And the first test we had them do was how long they could hold their hand in a bucket of cold water. And if you look at the panel on the left, there was no difference. The fish harvesters and the controls had the same. It was the same duration. There was no advantage. And then we asked the discomfort rating, and thinking that the fish harvesters would think the cold water, they would tolerate it better. It wouldn't, they may not complain about it as much. And the discomfort rating was the same. So it didn't appear that chronic exposure to the cold water actually made it any more tolerable. And if you look at performance, we thought that maybe if you've had experience working in cold water with cold hands, that you would do better. But when we had people, we tested them on pegboard test and the dexterity test. Now, the dexterity test was a test that required you to move some nuts and bolts. It's a standardized test that involved using a wrench and nuts and bolts. So it was a test of sort of fine dexterity, but a little more larger movements than the pegboard test. And if you look at both the room temperature tests and the cold tests, so the room temperature tests are the ones outlined in orange, and the cold tests are the ones outlined in blue, the fish harvesters actually did worse. They took longer. So their motor performance is not as good as the controls. Now, the next thing we did is we tested the sensory performance of the fish harvesters and the controls. And we used the voluntary test. That was the test where you press hairs of various diameters onto the fingertip, and people will report back what they can feel. So it's a test of tactile sensitivity. And the fish harvesters had they performed worse than the controls. So what we're hypothesizing is that the fish harvesters are experiencing non-freezing cold injuries. And what a non-freezing cold injury is, it's a clinical syndrome that occurs when the tissues are exposed to cold temperatures close to the freezing point for sustained periods. So there's not a lot of work done on these non-freezing cold injuries, but we think it's something that that may be much more prevalent than has ever been reported, and it's something that we'd like to do some sort of larger testing to find out. So our future work is going to look at optimizing training, looking at other ways of optimizing training, taking these findings and seeing what we can do in terms of equipment design. Maybe it's about having better glove design, a glove that still allows you to have tactile sensibility, but also provides some kind of thermal protection. And as well, maybe making recommendations about procedures, certainly in terms of how cold you should allow the hands to be. So I want you to show, just to finish up this video here. This video is a Royal Marine who's in a tub of very cold water. They're just doing a max grip test there, and then they're going to give him a flare, and you'll see him struggle to open up the flare. So, being able to use our hands when they're cold is critical. So we either have to change, and he's clearly unable to open this flare. So if he was in an emergency situation and his hands were cold, he wouldn't be able to be very successful. And I think as well, those of you who work with the cold water, you should think about the susceptibility that you may be exposing yourselves to. Hylal did a systematic review in 2016 in the British Medical Bulletin and did a review on these non-freezing cold injuries and highlighted a couple of factors that may predispose you. And it's possible to get these non-freezing cold injuries with just one exposure to the cold. And that can actually result in permanent nerve damage. There's certain ethnicities that tend to be more susceptible. In one study, African American men and women were 2 to 3 times more likely to suffer cold water injuries than their Caucasian counterparts. It's greater in men than women. Now that could be because most of the studies have been done in military and sporting situations where there happen to be more men. It appears to increase with age, with previous previous cold water injuries. If you've had them in the past, then you're going to get them again. Obviously, clothing. If you wear appropriate clothing, you can prevent them. And fatigue is an interesting one. If you have fatigue, you're more apt to experience a cold water injury. So I think it's just a moment to kind of reflect on our own practices and maintain safety in the lab as well as in the workplace. And I think I'll wrap up there.
Perfect, thank you. If anyone has any questions, you can go ahead and unmute yourself, or you can type it in the chat if you're more comfortable with that as well.
I have a question. It's very interesting presentation. Thank you very much for it. And my question is more, it's not exactly about your work, but about the program that you mentioned that is starting. And I was wondering if you could give like an idea of what kind of focus will this program have? That this new program?
The graduate programs?
Yes.
They're it's housed in the School of Maritime Studies with a focus on ocean safety, but we have a broad faculty interest in our faculty. So, for example, we have an engineer on faculty, psychologists. I have a kinesiology background, so it kind of depends on what the interest is of specific of your supervisor. And I'm working in simulation. Rob Brown does a lot of work in ship evacuation, modeling of ship evacuation. And Liz Sanley is working on sort of cognitive processing as that relates to ship navigation. And we have 2 new faculty that we're in the process of hiring, so there'll be new faculty coming on.
Thank you.
Hey, Heather, can you hear me?
Yeah.
Hey, Heather. So yeah, I just wanted to say 2 things, just kind of follow up on that. Hi, I'm John McDonald. I'm one of Heather's PhD students. It's a great program. It really has a lot of applications in the real world, from the implications on training, the implications of policy, that sort of thing. I'm currently I'm employed with the Canadian Coast Guard, but I'm looking at situation awareness and how that might affect kind of future training. I'd never heard of Wim Hof, Heather. That is a very interesting story. Do you think, this is a question I have for you, do you think there's really anything that you can like operationalize or like generalize from Wim Hof, or do you think that he is like a special case that kind of like a statistical outlier?
There has been nothing from a physiological. I think he's just sort of a real extreme character. What he proposes, there's no evidence has been, scientific evidence has been provided that kind of supports his claims. But he does these really outrageous things. So he's clearly able to do it, but there has been no evidence yet that the repeated cold water exposure actually hardens you to it. So I really don't know what to say. And the groups, there's been a group, they've done like MRIs of his brain, full physiological analyses of every aspect of his physiology, and they've been not able to find anything particularly special about him. So
yeah, that's what my instinct tells me as well. Yeah, it makes sense. Thanks. Excellent presentation, by the way.
So it doesn't look like there's any more questions. Thank you for coming, as well as thanks everybody else for joining in. We'll be putting up these talks on a YouTube channel as well, so anyone who misses it can gain access. And once we have that set up, we'll send out the link to everyone. Thank you all for joining. Thanks for coming, Heather.
Thanks so much.